NASA scientists are trying to find out exactly how fast the glaciers of Greenland are melting and moving water into the sea. Leading the team is Josh Willis.
This is a dangerous place to be. This is West Greenland, 220 miles north of the Arctic Circle, and we're looking at the Abernalich Glacier. It's a river of ice made up of snow compacted over thousands of years, and it empties right here into the ocean. At any moment, a huge chunk of ice could break off and crush a person if they were standing right here, or cause a tidal wave that would sweep a person away. But this ice isn't just dangerous because it's falling. The glacial flow of Abernalich is speeding up, just like glaciers all across the world.
15 years ago, this glacier was losing ice at a speed of about 3 feet per day. According to scientists' latest measurements, it has tripled its speed, now losing 10 feet per day. And it's not the only one that is melting faster. You are on the deck of a NASA research boat called the Neptune. This is the Bernstorff Fjord. Eric Rignot is a professor at UC Irvine and a senior scientist on the NASA team.
In the distance, about 3 miles from here, is Fimbul Glacier. Fimbul Glacier didn't used to be that far. It used to be much closer. In fact, about 100 years ago, it was right here. The glacier retreated more in the last 15 years than in the previous 70 years. We'd like to know why. This is why we came here. We think climate warming has something to do with it, and not just air temperature, because air temperature is not enough to explain this retreat. We think something is happening down below in the ocean.
We're downstairs inside the boat. The computers behind me are connected to a sonar that's scanning the shape and depth of the sea floor. That's important because the glaciers are sitting right in the water, and water is really good at melting the ice. Just imagine an ice cube melting in a glass of water as opposed to an ice cube left out on the counter in the air. The water is really good at melting ice because it contains so much heat, and the warmer the water, the faster it melts.
So to better understand how fast Greenland's glaciers will melt and raise sea level, scientists need to figure out how much of that ice is sitting underwater and how warm that water is. The NASA team is trying to measure this from the Neptune, but also from the air.
This is NASA 2, the Gulfstream 3 that is my home for about 5 weeks a year when we're in Greenland taking measurements. It's probably the most important platform we have for our mission because it allows us to get to every corner of Greenland in just a few weeks. The racks here communicate with the radar that we attach to the bottom of the plane. The radar measures the ice height and tells us which glaciers are shrinking and retreating the fastest. We also drop probes through a tube in the back of the plane. This is where we drop the probes through this tube. They fall to the sea floor and measure temperature and salinity. So when we get to the right spot, the pilot says 3, 2, 1, drop. Pretty soon, it's radioing data back from the surface all the way to the sea floor.